Well, we're ready to talk about one of the major items in counting. We're also making green splashes here. Permutations and combinations. Yeah. So a permutation, how do you make a permutation? It's a permutation of k items chosen from n items. So you have a bag with n items in it. You reach in there, you take out k, and then you put them in order. First, second, third, fourth, fifth, up to the kth one. So we've seen stuff like that. The dessert choices, the bank codes. You're choosing three from a cart that has 20 on it, and then you're choosing one and doing it in order. So you take one off there, and then another one off there, then another one off there. In order, you're keeping track of the order. And we said that there'll be n choices, 20 choices for the first go, and then 19 for the second go, and then 18 for the third go. And we said factorials help you do that. So here's the way you use factorials to just peel off the first few numbers and multiply together in decreasing order. You have a factorial there and a factorial here. Here's what it looks like. And so that means upstairs I got 20 times 19 times 18 times 17 times 16, keep on going like that. And downstairs I got 17 times 16 times 15 and so on, keep on going like that. And then what happens is we've arranged things so many of these guys cancel, and you're just left with the product of the three numbers we know how to do already. So this is just notation. It says I'm going to only pick the first k of these numbers. So when you choose 3, I'm just taking the first three numbers in 20 factorial, 20, 19, 18. We know that. And so here I'm going to just pick the first 4 of 10 factorial. So 10 times 9 times 8 times 7. Watch it happen here. So here's 10 factorial. It's 10, 9, 8, 7, 6, 4, 3, 2, 1. And downstairs 6, 5, 4, 3, 2, 1, all multiplied together like that. And then we do some canceling. I over-canceled myself. Here we go. And you just end up with the first 4 digits, or the first 4 numbers in the product that you're using to make 10 factorial. So the permutation formula, we already know how to do it. It's just, here's a way to express it with factorials. Here's a way to use a notation that shows up in the calculator. So if I wanted to say, find this one in the calculator, I would go 20, I go math, prob, and PR like that. And then I'd go 3, and then I'd hit enter. Let me make sure that actually works by doing it right now. So I'm turning on my calculator, I'm going 20, okay. Then I'm going math, prob, NPR, enter. Then I type 3, hit enter again, and I get 6840. That's what we got before. Okay. So that's the TI version. 20, math, prob, NPR 3, enter. Out it comes. So that's permutations. That's nothing fancy. Well, it's still a little bit fancy, but we use the counting principle to do it. Here's a harder thing to compute, is combinations. So combinations of k items chosen from n items. So now we're going to reach in a bag that has n items. We're just going to pull k of them out, and we're going to look at them. What did I pick? How many ways are there to pick k items from n? I'm not putting them in order. I'm just looking at them. So how many groups like that can you choose? So that's harder to count, but one way to analyze your thinking is break that process of making a permutation of k items into 2 steps. So first we choose the items, then we put in order, and that gives you a permutation. So if we counted the number of ways you could choose the items and called it that, then put them in order, once you have k items, there's k factorial ways of putting them in order, and that should be counting how many permutations there are. So we make a permutation by picking the items that are going to be involved in the permutation a certain number of ways, arranging an order a certain number of ways, multiplying them together to get the number of permutations. We take that equation and we solve for the counting question, the number of combinations, by dividing by k factorial. Pretty wild. And then that gives us n factorial over n minus k factorial divided by k factorial. So there's the formula. And then, well, there's some other notation for that. You might have seen it. The binomial coefficient is the same thing as the combination. Same as number of combinations. Okay. So we could change our dessert question to a number of dessert choices where we don't care the order. You just reach on the chart on the cart. You pull off 3 different desserts. How many ways can you do that? So that'd be choosing 3 things from 20 where you don't care about the order. The formula says you put the big number here, and then you put the number of choices here, and you put n minus k, which we used before in the permutation formula there. So for this one, it's 20 factorial divided by 3 factorial, and then you've got 20 minus 3 factorial, which is 17. And so you can see what happens there. A bunch of cancellation. Well, maybe you don't see it, but the 20 factorial and the 17 factorial have a lot of canceled terms. So it's 20 times 19 times 18 over 3 times 2 times 1. So that's there. So we'll have the original thing we had for the permutations. Then we're dividing by some extra business here, because when you have permutations and you care about their order, there's that many factorial ways to place them in order. So if you want to undo that, you have to divide by that thing you would have multiplied by to create that, which is this 3 factorial. So you can actually do this by hand, it turns out, just by canceling factors. So then I get 6 times 19, which sounds like 114 times 10. Is that right? 54. Yeah, is it 1? Is it this? I better check it out. 19 times 6 times 10. Yeah, 1140. Cool. And we could also get that by going like this. We go 20 math prob, then we go NCR, and then we type 3, and then we hit enter. I'll do it here. So 20 math prob NCR, get it, hit 3, hit enter, 1140. Okay. So we have the formulas and the calculator procedure. If you're interested in using the calculator to get these quantities, which you'll always have a calculator if you want to, we'll be using this quantity here when we talk about the binomial distribution. So we've done just about as much counting as we need, but we need to do some more examples, I think. Let's see what's on the sheet next. I haven't. Yeah, so we have a couple of examples. And then, oh, we have a bunch of examples. Oh, good. So it's all examples. Words with repeated letters, card hands. It looks like a full, particular kind of full house. Winning the lottery, and looking at an example of choosing hiking friends. So we'll be looking at some examples mostly of this on upcoming slides, and that'll end this section.